Okay, so for this question, they say post bosses in Malaysia randomly spits out and on average 5 both bosses are found per square mile. So average, it already gives you a keywords here. When we're talking about average, this is your lambda Poisson for 5 post bosses, 1 square mile. Determine the probability for your certain square mile. There will be exactly 7 post bosses and then less than 8. So for the question, first write out what is your x. This will be number of post bosses. So discrete, when you see number of post bosses, this is discrete. Distributed Poisson with average 5. This is for 1 square mile. So for the first question, you want to find probability exactly 7. So write out your symbol mathematics from the question first. Exactly 7, how to write it? It will be x equals to 7. So x equals to 7, you can use formula or you can use table. So if Poisson formula, E negative lambda power 7, then 7 factorial. Or if you use table, working will be different. Table will be x more than equal. You have to read more than equal. If you want 7, you start reading from 7. But after that, 8, 9, 10, we don't need. So we minus starting from 8. Then you will have remaining x equals to 7. Okay, so you can read from your table and calculate. So for your table, this one, 0.2378 minus 0.1334. So table Poisson 5 for your lambda 5. It will be in the page of lambda 5. So it will be page of 12. So lambda 5, reading of 7, 2378, reading of 8, 1334. So you can get 0.1044. But if you use calculator, decimal a bit different, you can give your answer more than 3 significant and will be enough. Alright, so what's the answer from this? 0.1044 also. Same. Then number 2. So how we translate this sentence? Less than 8, but not less than 4. Your number of post bosses less than 8, but will not less than means it will be starting from 4 onwards. So for this, if you use table, we will read for the reading starting 4. 4 is included, so we start from 4. Then 5, 6, 7 minus the reading that we don't need, not included here, 8. So reading for 7350. Okay, then question B, the number of pulses in a smaller area. So no longer 1 meter square, 1 square mile. It will be 1/4 of your 1 square mile. So 1/4 means 1/4 of your square miles. Therefore, your lambda will be different. So for 1 square miles, it gives you lambda 5. So when you 1/4 square miles, your lambda will be divided by 4. So lambda 5 divided by 4, it will be 1.25. So our new distribution here will be 1.25 for 1/4 square miles. So find the probability at this small area will be contain how many pulses here? Contain both pulses. So how many here? As long as it contain your both pulses, so how many there? More than equal 1. So the sentence here, as long as they were having your both pulses, so it can be having 1, 2, 3, and so on. So more than equal 1. Indirectly, they want to tell you. They want you to find more than equal 1. So 1.25 Poisson. Do we have this in table? So in table only one decimal. So we're not suitable using table. We can only solve it by using formula. If solving formula, we have to calculate equal. So it will be impossible for us to calculate equal 1, equal 2, equal 3, equal 4, equal 5, how many we need to calculate until the end. So we calculate it reverse back in reverse calculation, taking overall 1 minus the thing with the 1 minus x equals to 0. So for x equals to 0, Poisson formula E negative lambda, then lambda power 0 over 0 factorial.